Question 30, Electrical Engineering, GATE 2021. A magnetically coupled circuit is given to us and we are asked to find out the input impedance for this network. 4 options are given and all these options are in S domain. For a detailed lecture on this concept, please refer Module 7, Lecture 31, Laplace Transform of Circuit Elements by Professor Ankush Sharma, Department of Electrical Engineering, IIT Kanpur. Consider this coupled circuit. You have the current that is entering into this terminal, and because of the magnetic induction, this magnetic field and the current that is passing through it induces a voltage across the secondary coil. So in the secondary coil, the current flows in this direction. So the positive of this is here and the negative terminal is here. So the voltage is measured across these two terminals and this voltage will be the voltage across the secondary. So when the current enters through the dotted terminal of the primary coil and when the current leaves through the dotted terminal of the secondary coil, then the voltage induced by it, which is equal to S into I1, where the positive is at the leaving terminal and the negative is at the entering terminal. So the positive terminal is over here and the negative terminal is over here, because the current is leaving from this terminal. So wherever the current seems to leave in a load, then we call the positive terminal of that load to be the leaving end, and in the entering end voltage is negative. So this is the voltage of the primary, which is equal to S into I2, which is opposite of SI1. Therefore, the direction of SI2 is negative and the direction of SI1 is positive. Similar is the case in the given problem. The current seems to enter in the dotted terminal of the primary and the current leaves in the dotted terminal of the secondary. Therefore, the positive terminal of it is here and this voltage is S into I2. And this voltage will be plus and minus. This is S into I1. This is the dot rule. When the current seems to enter at the dotted terminal of the primary, the voltage induced in the secondary is negative. And similarly, when the current leaves from the dotted terminal of the primary, then the voltage induced in the secondary is positive. This is dot rule. By using this principle, we have found out the sign of SI1 and SI2. Let's begin solving this problem. Our objective is to find out the impedance of this circuit looking at the input terminals. From Ohm's law, we know that the impedance would be the voltage across the ends divided by the current that is passing through it. The voltage is not given to us. So let us assume that a supply voltage of Vin is supplied across these two terminals. When we apply KVL to this loop, we will get this in terms of the current I1, and when we apply KVL to this loop, we will get this in terms of the current I2. So by substituting the value of I2 into this equation, we will get the value of the input voltage. Let's begin solving. If we apply Kirchhoff's voltage law in the first loop, we will get Vin minus 4 times I1 minus 6 S I1 plus S times I2 equals 0. Separating the terms, we would be getting V1 is equal to 4 plus 6S times I1 plus S into I2. So this is the equation that we get when we apply Kirchhoff's voltage law in the first loop. Let's hold this and do the same for the second loop. In the second loop, the working current is I2, so we will be getting the equation in terms of I1 and I2. We will get S times I1 is equal to 4S plus 5 into I2. So from this we can observe that I2 is equal to SI1 divided by 4S plus 5. I am going to substitute the value of I2 in the equation that we formed earlier. I am doing this because our objective is to find out the input impedance of this circuit, for which we need Vin in terms of I1. So we have to replace I2 in terms of I1. That is why I am finding out the value of I2 from the second loop and then substituting it in the first equation, so that we will eliminate the unknown term and then we will form an equation with the terms that we require. So once we substitute that into the equation, we will get Vn is equal to 4 plus 6s times I1 minus s into SI1 divided by 4s plus 5. So the input voltage would be, since we have I1 common in both the terms, we can take that out, and Vn is equal to I1 into 4 plus 6s minus s square divided by 4s plus 5. So this implies that Vn divided by I1 will become 4 plus 6s minus s square divided by 4s plus 5. So when we take LCM, we will get the terms 4 plus 6s times 4s plus 5 minus s square divided by 4s plus 5, which is 16s plus 20 plus 6 into 4 is 24, 24s square plus 30s minus s square divided by 4s plus 5. Vn by I1 is nothing but the input impedance. So from this we get the input impedance to be 23s square plus 46s plus 20 divided by 4s plus 5. So from the given options, we can understand that the option A is the correct answer. The input impedance Zin of S for the network shown in the figure is 23s square plus 46s plus 20 divided by 4s plus 5, which is option A. Thank you.